Now we're going to look at logarithmic functions and models. Logarithms. Why should we have to worry about logarithms? Well, if you want to find the number of payments on a loan or how long it might take to reach a certain investment goal, maybe you want to measure the pH or acidity of a chemical solution. What about earthquakes? Earthquake intensity on the Richter scale. It's also used, to analyze exponential processes such as there's applications including cooling of a dead body, growth of bacteria, the decay of radioactive isotopes. So you see, guys, logarithms are here. They're there, and we do use them. You might not ever have to use them again, but some of you all might. So, starting off about logarithms and exponents, well, a logarithm is just an exponent. That's all it is. Nothing else. A logarithm is just an exponent. Look at this particular problem. This is a conversion rule that you've got to know. Notice this is a two-way arrow. So I've got y is equal to log x base b. I like the b here, and I like to read it that way because when I have to rewrite this from logarithmic form to exponential form, here's my base. That's my exponent. Remember, a logarithm is an exponent, so b to the y would equal x. Now, my base cannot be 1. That sort of sounds familiar. The base has got to be greater than 0, and x has to be greater than 0. Remember, this right here is my exponential version, okay? And back then, our bases were not equal to 1, and they had to be greater than 0. Now, another thing we looked at before we got to here were inverses. Just say, for instance, come on, I've got this piece right here. Let me delete that. Say I have y equals b to the x. Remember, for us to find a rule for an inverse, we interchange the y and the x, like I've got right here. Wherever I've got y, I put x. Wherever I have x, I put y. And the other thing we had to do is we had to solve for y. Well, the only way we can do that is by using logarithms. So this right here would be the inverse of this. So exponentials and logarithms are inverses of one another. So let me just get rid of this whole thing, because we're not going to worry about that right now. Special logarithms, these are on your calculator. There's a log called a common log, which is base 10. This is right here, your log. That's base 10, called the common log. The natural log, or shortened to ln, right here. Here's my n, here's my l. So ln of x is the same thing as log x base e. So look right here. Here's my ln. And notice, see the e right above it? See the 10 above this one? So log is my common log. Ln is called my natural log. So the first thing you're going to have to do with logarithms is be able to go from one version to the next. So change each exponential expression, notice all I have is exponents down here, to an equivalent expression involving a logarithm. So the first thing normally I do is I get my exponent, so my exponent equals log, pull my base, and equals my number. So let's see what I've got here. Maybe write an equals and log. 4 is your base here and here. A logarithm equals your exponent, and then you have your number at the back end. If you'll notice, I've got 3 things, and if I know where 2 of the 3 things go, then by default, I know where the third one goes. So you try this one. Know who your exponent is, know who your base is, and then finish it up. So you should have 3 equals log n base 2.2. Exponent equals log, my number, my base. So base goes base, exponent is what a logarithm equals. Try this one. Let's see, you should have 2.2 equals log m base e. But remember, this is one of the special ones. So instead of having log m base e, another way to write it is 2.2 equals natural log of m. So if you have that, technically these two are the same thing, but your instructors will want you to start writing anything that has a base e as an ln. So that's the first thing you've got to be able to do. Go from exponential to logarithmic. And of course, then you've got to do the exact opposite. Change each logarithmic expression to an equivalent expression involving an exponent. Well, these aren't so bad. Here's my base. Here's my exponent. So 3 to the negative 2 would equal 1/9. Base, what's my base here? Base is pi. Exponent is 1/2 equals my x. That's sort of pretty. This one, remember what the base is if you see ln? The base is e. If you don't remember, look at your calculator. Here's ln. There's my base right there. So e to the 4th equals x. Now if this had been log, then my base would have been 10. See, there's special inverse properties. The following inverse properties hold for logarithms with base a. So if I've got the log of a number raised to an exponent, but this number here is the same, exact same thing as my base, then it will equal x. For instance, let's look at this. Log of 100. Think about this. This is base 10. Now if I rewrite this as 10 to the 2nd, then my answer should be 2. There it is. That's all this is saying. This number and this base must be the same. If they are, then whatever the exponent is what this equals. Try another one. Let's try log of, here, I'll just go 10 raised to the 4th. This base is the same as that number, so this should equal 4. So let's see if it does. There it is. Now this one, check this one out. I've got a raised, now this is my exponent, log x base a, this equals x. So again, if this base and this base are the same, then whatever this number is what your value is. You don't see this one that often. Every once in a while it pops up. You'll see number 1 more. Now another thing I looked at right down here is if I rewrote these. Now this is in logarithmic form. So if I rewrote this to exponential, it would be a, this a, raised to the x would equal my number. So you see, notice that that's true. This one is in exponential form. So if I change this to logarithmic form, my base is a, okay? My exponent is right here. Big exponent, but it's still my exponent. And this is my number. So check this out. So this is my exponent. Think about that. That's my exponent. Here's my base. So that goes here. And my number goes here. So you notice it's true. So some of the problems you're going to have to be doing, the bases will be the same. So you need to see which one of these special inverse properties you'll have to use. Okay? That's it for this one.